So this morning, I will start off with introduction of Kepware, introduction of Allied Solutions and Kepware. I will then pass on to Steve from Kepware to talk about Kepware latest release updates and secure deployment, which Ken from ST Engineering will further talk about the use of Kepware with their industrial data diode. ST Engineering data diode is fully tested with Kepware. You can also download the detailed information from Kepware website. Lastly, we are happy to have Elvin from Stratus to talk about high availability deployment of Kepware with Stratus. A brief introduction of Allied Solutions. Allied Solutions is a Singapore-based company, headquarters in Singapore, and we have offices in Singapore, China, Indonesia, Malaysia, and Vietnam. We are focused in providing automation system, industrial and manufacturing software, industrial cybersecurity, fault tolerance and high availability platform to run our software, as well as we have 100% owned subsidiary Avanca that does all the industrial networking products. Our solution and services is being deployed in all types of industry over the years. We have a wide spectrum of domain knowledge to provide the right products and solution to our customers. Now let's move on to Kepware. Kepware was established in 1995. And since then, Allied Solutions has been their partner since 1995. And Kepware is currently the top company in industrial connectivity platform. CapServer EX is Kepware flagship products and is an industrial leading provider of asset connectivity in the market. CapServer EX provides the library of...
Yeah, I'm hearing.
Is it okay? Yeah, let me continue. Yeah. CapServer EX offer a library of 150 plus device driver, client drivers, and advanced plugin for connectivity to different devices, such as PLCs, RTU. PLCs can be made, all the major brands of PLC vendors like Allen Bradley, GE, Omron, Schneider, Siemens, and many more, or industrial initiatives like MT Connect, DMP3, IEC, and BugNet, and so on. It also provides access to client applications like ERP, MES, HMI, and SCADA, and proprietary protocols, as well as IoT visualization and analysis products, VAL, MQTT, REST, and other IT-centric protocols. And CapServer EX is tested by independent agencies, industrial automation users, and internal stakeholders, both to secure the highest product quality. Here's a very good diagram to illustrate what CapServer EX does. So you can see that the Caps EX server is in the center here. And from the southbound connectivity in the plant, we have equipment such as PLCs, Yukon drivers for barcode reader or check weigher. In the building automation, we have protocols such as BugNet, and some of the specialty drivers like ABB Total Flow and other oil and gas products. And we also link it to different IT products through SNMP. So by linking to all this data, we bring the data up to the northbound client applications such as HMI and SCADA software. We also have a dedicated driver for Splunk and ThingWorx. And if not, we use the REST and MQTT to bring it up to different IoT products. We could also bring data to any ODBC compliance database through our database connectivity. And Through bringing the data securely through different locations, we use our OPC UA tunneling solution, which we will be very focusing in this webinar, together with ST using their data diode. In summary, companies normally need to overcome several communication challenges present in automated environments using many brands of drivers in order to gain access to industrial data, just like the diagram here. So with Kepware, it provides a single platform collecting, aggregating, and providing secure access to the plant industrial automation data. You could download the Kepware software from the Kepware website, and you could run it for 30 days. If you need more, please contact our sales and we'll be able to assist you. Okay, let me see if there is any. Okay, with that, I saw a question here, but I think my colleague Steve is answering it. Okay, with that, I will pass on to Steve from Kepware.
Hello, good morning. Let me just share my screen. Can you guys see my screen?
Yes.
Okay.
Steve.
Okay, hi, good morning, everyone. I'm Steve. So for those who are not familiar, I'm actually the application engineer based in Singapore. Right, so I'm happy to talk to you today and thank you for taking your time to join into our webinar hosted by Allied Solutions. So today I will kick off with a little bit of product updates. So this session of the presentation is kind of to let you know what is our latest release and what is upcoming on our roadmap. Right, so as Ching Pei has already briefly discussed about the company layout and things like that, I'm going to just summarize it with this diagram. So pretty much for those who are not acquainted with Kepware, right? So we are a PTC company, and in this diagram you can see that what we really do, right, is that we offer you a bunch of industrial assets drivers that allows you to connect to them, and we consider them as data source, right? So your field controllers, field devices can be connected through a software like Kepware, right? And I believe that right now in the market, we are the leader in the sense that we have the highest number of drivers, right? And we are a commercial off-the-shelf solution, right? So from there, once you get the data into the platform, you are able to actually send it out into various stakeholders. So it could be a traditional OT kind of environment where we talk about OPC, right? Or we could be talking about, even cloud services when you're implementing IoT solutions, right? So that's some of the capabilities of the platform itself. So CapServer EX really is a communication platform. Let's consider ourselves as a communication platform, right? And it's widely used across the industry at this point of time, right? So in a more macroscopic view, this is how the software sits in an OT environment. So you can see that we actually have broken this up into a couple of layers. So if you look at the black color portion, that's actually the AS layer, right? Or the field automation layer, where we actually send data from the sensors. Your field devices are producing all this data, in a cyclic manner. And that data is being ingested and treated through maybe an RTU or even a field controller, where after getting the data, it typically is being sent to a SCADA, right? Or HMI. So CapServer EX offers the capability to talk directly through a controller or even a specific specialized device like a flow computer or even the HMI or SCADA systems, right? Once we aggregate the data itself, what we can actually do is that with that data, we can actually send that very same data used in production across to other platforms for other specific users. So for example, in the OT environment, we have historians where we are logging data, OSI Pi and things like that, Wonderware Historian. And then we have SCADA systems such as iFix, Wonderware, Ignition. So these are some of the typical SCADA systems. Then, with the upcoming IoT applications, we also offer the capability to send that data into cloud, where you can further perform, stream analytics, or even leverage other cloud services that you probably cannot do before. Right, so this is the macro view of what our software offers. And to top you off, for the key focus of us really is on the connectivity layer as a foundation for IoT, right? So this is actually eventually the guiding vision of how we see ourselves and push out the developments along the way, right? And then our sister company, ThingWorks, is actually the one that deals with the rest of the IoT vision and capabilities. Right. So for those who are not familiar with Kepware, again, when I say commercial off the shelf, what it really means that our software is designed to be user configurable. So any user who is trained in Kepware should be able to operate the software by themselves, right? Rather than taking every single connection as a project, or you hire like a specialized system integrator to develop the software. So what we offer is an out-of-the-box solution where you can actually download it and quickly get your connectivity up, right? Every quarter or so, CapServer EX will actually, or rather Kepware will actually release a new update or enhancement patch or a minor update, right, to the customers, right? So if you look at the left corner, which is this corner, right? So this website called mykepware.com. So if you type into that website, you will be able to download all the different versions of CapServer EX that we offer right now. So today, the latest release right now is 6.10, and I believe that 6.11 is coming soon. So stay tuned for that. But today, because the 6.11 has not been out, I will talk generally on 6.10. So for release 6.10, these are some of the high-level goals that we had in mind. So we actually want to enable system integrators and partners to connect to second and third-tier devices. And in doing so, what we discovered is that these devices typically have various combinations of protocol requirements. So in that response, we have developed the new driver, which is called the UDD driver. So a universal device driver, right? Which I will touch on later on to explain on what it really does and things like that. The next thing that we wanted to do is to provide functionality to further support the enterprise deployments. So with that in mind, we actually have the Dockerized CapServer EX, or rather the Linux version of CapServer EX, released into the market. So the TKE 1.3, I believe, supports the Docker containers today. And on the third objective, which is our core objective usually, that's where we want to maintain our top-tier driver support. So in that sense, we actually provided some sort of updates to the Allen Bradley drivers. So we now support version 33 firmware, right, as well as the TIA Porter version 16. Okay, and last but not least, security is a key focus for our development. So we consistently will actually patch the software to improve our security stance and enable the technical debt reduction on your end. So the UDD driver is actually a new driver that we now offer through 6.10. The driver itself provides a flexible and dynamic solution to create custom driver profiles. So what we really mean, right, is that this driver is actually sitting together with, for those who are familiar with Kepware, the Yukon driver and the CID driver. So for those who are familiar, the CID driver offers a way to interface to third-party SDKs via .NET, right? And for the Yukon driver, what it does is that it offers you a GUI, a graphical interface to kind of develop your own custom driver profile. So typically, when you will use any of these drivers, you are in a situation where Kepware do not have a ready-made driver for you to go. Right. So now we have another option called the UDD driver. So the UDD driver, the biggest difference is that it's a scriptable driver, right? So this driver itself actually does offers you to script out your driver in JavaScript, right? So if you look at the bottom left corner, you can see that these are some of the profiles that we offer today. So you can see that right now, we only support TCP, and it will be a solicited Ethernet profile. So for unsolicited communications, that will be supported in the next upcoming release in 6.11. So these are our very, very first initial release, right? So what you can do with this driver, right, includes things like you can actually write out your HTTP call to interface with an API. So you could be gathering weather information from, say, openweather.org, or you could be interfacing with an API from a robot, for example, an MIR robot platform, right? They offer API. You can actually script out that solution to talk to them through the UDD driver. So typically, previous to the development of this driver, typically what you will do is that you will probably have to write a middleware script to bridge the communications between Kepware and the third-party interface. So right now, we offer the capability for you to use JavaScript to be able to do some of that capability, right? So if you are interested, again, feel free to reach out to the sales team at Allied, or just pop a question on the Q&A. The next thing that we have done is that we are changing some of the terminologies used in our software. So terms like master and slave will eventually be phased out and replaced by clients and server, right? So again, clients is actually the master where you initiate the communication. Slave will be replaced by server where you listen for the communication, right? So this is going to be a broad sweep approach where we will replace the terminology in documentation, in the interface, and things like that. Right, so don't be surprised when you use your Modbus driver and we no longer call it Modbus master, call it Modbus client or something like that. The next thing that we have released in this release that I apparently have missed out is the Yokogawa GX Ethernet driver. Right, so we now support the Smart DEC Plus product family. So if you are using the Smart DEC Plus products today, right, we now support them, specifically the GX series, GX10, GX20, GP10, and GP20, right? So for those who are interested, these products are also used in some of the COVID-19 vaccine development. Okay, so the other side release in the Fanuc Broadcast Ethernet, we now enable 2 new parameters on the Fanuc SDK, which is the CNC RD Timer. So the RD Timer allows you to read 5 different timers from the device. And the second one is the CNC RD alarm message, right? So this is something that I think a lot of our Fanuc customers are looking forward to. So this allows you to read the current alarm information, such as the number, the type, and the message, right? So with this connectivity, now you actually have the capability to monitor your CNC machines for some of the alarm messages that can be popping up from the machine. The next, we have the Allen Bradley Control Logics Ethernet update. So we now support version 33, right? So Logix 530, Logix 5580. And for the MT Connect driver, for those who are in the machine shops, you're using MT Connect driver, we now offer you a capability to actually skip the schema validation. So for those who are familiar with MT Connect, so the payload that they usually use between the MT Connect drivers is the XML file. Sometimes the machine that you are interfacing to, for some reason, the XML has a certain, maybe there's a typo or there's some way they develop that doesn't really conform to the proper schema. So now we have a capability for you to ignore that schema validation. So we can ignore that it's not a properly formed schema, and we just continue to pass that message. And on the other side of things, we have differentiated 2 specific drivers, which is the Allen Bradley DH Plus driver and the set bus serial. So that was a very, very big summary of the 6.10. So new drivers, new security patches, and new device support, right? So beyond that, so moving ahead, this is actually our roadmap. So just to share, I noticed that some of you are our Cap customers here. So just to share with you what is our intention for moving ahead in FY22. So our key goals are summarized by these 5 pillars. So the first thing is to maintain the drivers, right? So the market leading connectivity for brownfield and greenfield. So that's pretty much our core bread and butter, right? We will continue to do that. The other thing is that we will be releasing a bunch of features that will be targeted towards enterprise deployment, right? So we have reached out to a lot of our enterprise customers, and there are specific features that are required or it will make it easier for them to quickly deploy Kepware across the enterprise. Next, we are going to involve Kepware offerings to support modern IoT deployment architecture. So specifically, if you're in software development, we're talking about microservice architecture. So in that end, we as of today, we have the Dockerized containers for the TKE, and we are going to move forward to further develop the drivers for that particular line in order to support the kind of architecture. Fourthly, we are going to enhance our remote management capabilities. So there will eventually be a solution, right, which allows you to remotely monitor Kepware, right? So stay tuned for that. And last but not least, security, quality, and reliability is a key pillar for our end. So we will continue what we are doing today. We'll patch any issues, find any security holes, and we try to patch them as fast as possible, which we will elaborate a little bit later on. So moving ahead, this is our current roadmap. So the 6.10 has been released in the February 2021. 6.11 should be releasing fairly soon within this month, right? And then these are just some of the strategic priorities and teams that we are moving forward, right? So if you have any questions on where we are heading to, any specific drivers that you are interested in and we do not have it today, reach out to the sales team of Allied Solutions so that we can be aware of that. So today, this topic is actually part of our initiative to talk about the OT security, right? Because I think for us in the OT sectors, cybersecurity is a real threat that's up and coming, and we have to raise some awareness on it, right? So the key purpose of this webinar really is just to share with you from our experience and from Kepware's perspective on our software, as well as we also brought in, fortunately, we actually have a few other partners that are involved in OT security that will be able to share with you some of the technologies that they have deployed and have been tested to be working with Kepware fairly well. All right. So for my section, I will be generally talking about some of the best practice and going through some of the parameters in our hardening guide. So a lot of our customers today don't know that Kepware actually have a secure deployment guide, which is some of the best practice that we recommend for you to actually secure and lock down your CapServer EX deployment. So for OT security, so as Gartner predicts by 2025, cyber attacks will have weaponized the OT to inflict harm on humans. So unlike OT systems, sometimes when you see some of the IT attacks, probably the web server down, it could incur definitely financial loss. But for OT, right, when things happen, it could actually incur human loss, right? So life can actually be lost because of the nature of the systems that we operate in, right? For example, if an OT attack on a safety system or even a faulty sensor, right? For example, in the BP explosion, the HMI was not responding correctly, or the sensors were not responding correctly. So all these things can cause life loss, right? Which is difficult to quantify, right? Then for those who are familiar in OT security, Stuxnet is like the de facto use case for that. PLCs can be attacked. And then recently we have the ransomware attack on the pipelines. So all these things are up and coming. So as we are all fellow OT guys, we should be aware of these kind of things and try to do our best to secure our deployment. Oh, so I put out a link here. I believe the PDF will be sent out later. So the link over there is actually a pretty good read, for if you are interested. And then the next thing we can talk about is the NIST framework. So if you go to the link that I provided over here, you can actually see some of the OT specific security recommendations that by NIST, right? And with that in mind, I actually screenshot some of the stuff that they recommended. So additional steps that are supposed to be built onto. They actually have another above section that says mandatory. recommended. So these are additional things that we can do, and this is all the areas that we can work on from our perspective. For example, from our end, deploying a Kepware, if the system integrator deploying the Kepware, you want to, after you finish your project, start to do the best practice guide for security, right? For example, you disable unused interface that you're not using. If you are doing, some sort of movement of data across the LAN, or even, you may want to consider, instead of using the legacy protocols that are unsecured. Oh, sorry, I just realized my voice is breaking up. Give me a moment. Let me try to reconnect. Testing. Better? Okay. Sorry. Still the same. Okay. The line is back. Okay, let me see. If I Hello, testing.
Yeah.
Better? Sorry. I didn't know. Okay. Okay, so as I was saying, right, so as if we are doing your Kepware system integrator today, I encourage you, to actually go and try to disable the unused features where applicable. And if you can move away from unsecured protocol, move away from the unsecured protocol, right? So things like, OPC DA, is obviously, well understood, and it might be easier to implement, but sometimes, there's a lot of security flaw in that protocol. So if you can, really the reason is that most of our industrial protocols today are designed with availability and determinism in mind, right? And in doing so, sometimes we assume that the network that we have is in an isolated environment, right? But nowadays, as we start to see like IT and OT converge, that's where really the key challenge is for a lot of us, to how to figure out how to do that in a safe manner, right? Safety, very important, right? Last but not least, make sure that your Kepware is always the latest version, right? Because we do release security patches on and off with every release that we have, right? Because security is an ongoing thing, it's a never-ending journey. So we need to keep your system patched. Of course, again, in the OT environment, it's not that easy, right? Like a lot of us know that we have to schedule downtime in order to do that. But keep that in mind. And then on the other end of the things, we can talk about the network segmentation. So today we have ST Engineering, which is going to introduce some of the data diode solutions that they have, right? So a data diode allows you to enforce unidirectional flow, right? So if you're electrical engineering, you probably have seen this diode thing quite a bit of time. So it's actually a hardware with a certain properties that enforce that. All right. So that will be presented by our friend at ST Engineering later. Then in terms of disaster recovery and availability, that will be where Stratus shines in terms of their solution. So Stratus will be actually presenting on their solution with that respect. And then last but not least, like what Chin-Pei mentioned, we actually have a plugin for Splunk, which is a SIEM, right? So the key session of that is to showcase some of the parameters that you can pull out using the configuration API. So that will be the gist of and really the flow that we will be going on for today. So without further ado, I'll just go straight to my section, which is the Kepware Security Best Practice. Okay, again, if you are a user of Kepware today and you don't know about it, we have a secure CapServer EX deployment in this link posted over here. All right, so click on the link or you just Google it, you should be able to find the PDF. So what it does is that it covers some of the best practice and recommendations for what we think would be some of the best things that you should do, to secure the deployment. Again, if you want to do any of this and you have some queries, consult the preferred distributors for more information. So for Singapore, it's actually Allied Solutions, right?
So these are some of the additional resource that I find it quite interesting for you to take a look, especially on this part. So OPC Exposed is a pretty good document to take a look at, right? For those who are dealing with OPC, especially OPC DA, you know. So the best practice summary are outlined on this particular deck. So you can see that this is pretty much what we are telling you to do, right? So the first thing is called installation validation, right? So only get an installation from official sources, right? If you have to share the installers around the company, make sure, you know, go and do a hash file check to make sure that the file that you get is the same signature as what we have released, right? So for those who are not familiar with what's hashing, right? Hashing is actually a one-way function where if you throw in a bunch of text, it will generate a unique bunch of text. And in the security perspective, they call it digital signatures, right? So you can actually see, sorry, not signature, but a fingerprint. So you can actually check the strings that are generated out and match against our official strings. So you can be sure that that file has not been tampered, right? So this is one of the things that you ought to do if before deployment or when you're installing CapServer EX, right? Then for those who have been using CapServer EX for quite some time, you realize that in version 6, right, onwards, we actually implemented a lot of the permission controls and enforces password configuration. So during the installation, there is a portion where they will ask you to actually create a password, right? So of course, you know, from a project perspective, you probably have just skip setting a password at this time, but make sure that you enforce a password after you are done with the system, all right? So that you can prevent people from unauthorized access into CapServer EX, and then they can do all the funny stuff. Okay, the next thing that you need to know, right, is that in the CapServer EX software, right, is by default the application data is installed in this folder, c/program data/Kepware, right? So if you go into that folder, you can actually see some of the application data, for example, the default runtime and things like that, right? So what you really need to do, right, is to go into that folder, right? Go into that folder, right-click properties, and then remove the permissions that are unnecessary, right? So the default permissions probably might be too much, especially if you're system administrator. So remove some of the permissions that are not required, right? Swap it to a read or even instead of a full control, give you a read only executable, or sorry, give you a read only permission access, and then fine tune that. So the instructions are all listed out in our PDF that I talked about just now. So this is one of the steps that you probably need to do, right? In OT usually we go in straight as administrator, so that's something that we also need to be cognizant of, right? Everybody has administrator access. What does that mean for for security? Okay, the next thing is something that is quite obvious, but it's hard to enforce sometimes, right? So interfaces that we have are disabled by default, but sometimes during your troubleshooting, or maybe another system integrator comes in, and then maybe you have enabled something along the way just to test certain features, right? So remember to disable those that are not used by default, right? And if you don't need OPC DA, you should disable it. All right. So this can be something difficult to manage, because a lot of times when we do troubleshooting, we'll ask you to click on this small little button over here to read the data of the platform using OPC DA, right? Quick clients. So, but what you can do is that you can, after troubleshooting and everything is done, you can disable the OPC DA interface if you are not using OPC DA, right? If you are not using OPC DA. So if you are fortunate enough to have a system that comes with a UA, OPC UA clients, you can actually move away from OPC DA. You can actually do that, right? And then if you are doing OPC DA, right? If you are using OPC DA, make sure they are doing it in the with the proper DCOM configured. So if you go to check out Kepware's remote configuration guide for OPC DA, if you follow that steps, right, you will notice that what we have done is that instead of asking you to create a DCOM directly into the open up the entire DCOM. What we ask you specifically is to create a group for OPC users, and then park users that are required to access the OPC DA interface under that group, so that you can actually manage the permission. Right. So that's really one of the core things that you need to take note if you're dealing with OPC DA, which can be pretty tricky, right? So just bear in mind some of the things that you can do and operate accordingly in the field. So for the interfaces that we have, right, just to talk about it, when you go under the CapServer interface, go under the project. So there's the word project over here. You right click on it and then click properties. So this is the part where you can actually see all the different interfaces that we have on the server end. So the server side of the software, right? So we have the OPC DA, OPC UA, DDE, AE, HDA, and Teamwork. Right. So these guys, if you don't see any of them, please disable them. Okay, next. Not a lot of people know about this, but CapServer EX, right, comes with a security policy plugin. Sorry. So the security policy plugin, previously in version 5, is a chargeable plugin. Right. From version 6 onwards, we actually give it out for free. And really, the key reason again is because with what we are seeing, we feel that this is a mandatory feature that should be built in. So in Kepware, right, you can actually create users, right? So if you look at this section over here, under your Kepware administrator, which is a small little icon at the bottom right corner of the system tray of Windows, right? If you click it, right-click settings, you can actually see the system manager. The user manager. So by default, when you log into an instance of Kepware, you are assuming the administrator role. So you can actually disable it and then create other administrator users, and enforce password and things like that. So that's one of the things that you can do. On top of that, once you have that user segregation, you can define which user can access which capability of the software. For example, if let's say you're using OPC UA today, instead of the anonymous login, you can assign an OPC user username and password, and then designate what are the tags that he can see and whether he has the browsing capability to browse the server, right? So permission segregation and things like that, right? So this allows you to create the authentication and authorization required in order to get into the software, right? So these are the interface that the username and password are used, right? So if you implement any of this, they can be leveraged on the IoT gateway, which allows the HTTP calls, right? The OPC UA server. So on OPC UA, you will be able to use the username and password to do authentication, and the configurator itself. So the configurator itself is actually the interface where you configure CapServer EX. So when you launch Kepware, they can actually prompt you for username and password before allowing you to do anything, right? So these are some of the hardening steps that you can do. So one thing that you notice is that OPC DA is not listed here. Again, OPC DA is because that's because it depends on DCOM, which is managed on the Windows level. So that will again roll back to that remote config guide that we have from Kepware. Yes. So there's a point where if you notice on my end there is a part that says that looks like this. So this is actually an LDAP integration. So for the subscription version of Kepware, which is called the ThinkWorks Kepware server, used in this screenshot, this guy, right, is actually will allow you to actually use the Windows. You can actually add in a Windows user. So rather than application-based user, you can actually go straight to a Windows domain. So that is achieved by clicking this very nice icon here that looks like a globe. If you click it, you can actually see you can actually select the Windows user to actually talk to the software. Okay, so again, for securing of the configurator, if you go under tools and options, you can actually enable this user login dialog. So when you do that, what will happen is that the moment you open the configurator, right, it will prompt you for the username and password. And then if you type in something wrong, right, you can see that we actually locked lock it into our events log to tell you that there's an attempt and it failed. Right, so for OPC UA, again, anonymous login are disabled by default. So sometimes, if you are doing testing, you could probably enable it. So remember to disable it, because there's no point if you enable the anonymous login and enforce username and password. Doesn't make sense, because if the guy don't key in anything, he still can connect, right? So remember to disable it, and ensure that it's disabled to this same point as I talked about. Use the security policies to define what the user can do as well, right? So going back to just now that page, on the permission settings, make sure that you only give what is required, right? Least privilege access. Right. So as part of our software development, if you find any issues with our software or any bugs or something like that, you can actually submit a report in English to this email address, cvd@ptc.com. Right. So from here you can actually check out. You can actually submit a report, any known vulnerabilities that you may have found, and then you can actually use our PGP public key to encrypt the message, so it's encrypted, right? So every patch that we release, when we find some new things, right, we will actually disclose them under the CVE list. So if you go to their web page over here, right, cvemicro.org, something to the micro attack framework, you can actually see, you just type in the Kepware stuff, you can actually find the things that we reported, right? So today, if you are using a unpatched software that we have, for a specific build, you can actually see that if you are using CapServer 4 component, the PLC driver has some issues. Things like that, you can read it out. So you see this is something very frequent. See that 6.0 to 6.9. So today we are at 6.10. So every single Kepware version prior to 6.10 has some known vulnerability, right? But again, this is very specific to OPC UA. So if you have an OPC UA, you're using OPC UA, there's some sort of issues going. There's some issue going on there, but we actually have patched it. So make sure to patch your software. That's why we think patching is very important. So make sure you're using the latest version that we have. So that is the end of the from the perspective of our software itself, right? So Kepware software, all the things that you should do. So I think before I jump over to this section, what I'll do is that I will just do a quick show on where are all the parameters that we have. So I'm going to just launch my configurator. So this is the Kepware configurator. All right. So if you look at the right click on the properties on the project, you can actually see all the server interface that we have. Right. So the DA is over here. So if you're just using OPC UA, there's no need for you to enable the DA portion. So you can just disable everything here. So 1.0, 2.0, 3.0. Right. If you're using OPC UA, right, anonymous login should be disabled. Right. So what it means that if this is disabled, you will need to use the username and password to log in. Right. So again, that can be done through the Kepware admin tool. Right. So if you look at your bottom right corner, there should be a small little Kepware icon. Right click settings on it, you'll be able to see this page. So go under user manager, you will be able to create the user. Right. So for example, if you are using the subscription version, you can actually look for the Windows user, right? So this is the domain integration that we have, right? If not, you will be using a specified user username and password that is stored within the application itself, right? So these are some of the stuff that you can do. So you create a user, and under security policies, you can then define out what are the permissions given to the particular user group. What can they do? Maybe you want to deny they can only read the certain OT data or things like that, right? So that would be the security policies. Again, in version 5, it's actually a chargeable plugin, right? So for version 6, it's actually built-in free. So if you're using version 6 today, you can use these features directly, right? And then if you're interested to find out what is the current build that you have, go under help, support information. You can actually see the date code. So this is 6.10.623.0, right? So moving on to the next section, we talk about protocol. Right, so a lot of industrial protocols can take several forms. You know, it could be a standard TCP/IP, which is an Ethernet-based kind of driver, or it could be a field bus, right? Specific field bus such as Profibus. It could be serial RS-232, 422, 485, you know, standard stuff, right? So sometimes, you know, security implementation might not be possible because of the need of the performance, right? So again, in that kind of situation, you know, what you want to do is try your best, right? Try to have as much network segmentation as you can, or even, you know, deploy an IDS to monitor the flow or things like that, right? Because to be honest, our OT traffic is quite specific, very consistent in terms of the flows. So when you move data out of a layer, so you know, in a lot of nowadays we get involved in IoT. Sometimes we need to share the data to another system, right? So that's the part where complications come in, right? Because we need to connect the OT system to an IT system. So that's the scary part, right? When we connect to anything to the outside world. Because again, you know, most of our OT stuff used to be that it was isolated, right? So you know, and that means that there's an implicit trust that whoever is touching the machine is an authorized user, right? And then we have like physical security to take care of that. But you know, with all the IoT things coming in, you know, we need to be careful of some of the things that we do. We cannot do it in the same way as we used to do in OT, right? You need to be careful because the nature of our industrial protocols is that they are in plain text, right? What it means is that if someone, you know, some guy is sitting down there and he has somehow managed to get a wire capture for your system, right? They harvest it, right? And you wouldn't know, right? It could be a compromised switch, or you know, some vendor take a USB drive and then plug into your system. Over 10 years time, you don't know what is in that system anymore, right? So the moment you connect, you don't know what will happen, right? So there are some of the things that you need to be careful of, and really that's some of the issues that we have. So when we talk about when you really have to move data across the wire, right? What you want to think of is whether your system is it encrypted, right? The protocol, is it encrypted? Is there signing so that you can be sure that whoever is coming to get your data is the real guy, not a impersonator or things like that, right? So on our end, you know, anything that is encrypted would be our recommended approach. So you can either choose the OPC UA or, you know, HTTPS. So this is an example of how it looks like. You know, if let's say so you have an industrial asset, you know, for example, and it's talking in plain text. So you say hello to the SCADA, right? And then somehow the switch in the middle is, you know, compromised, or even somebody do an ARP attack on you. You know, they can actually see what you're trying to say. And the problem is that most of our industrial protocols, right, they are documented. So anyone, you know, who have enough time and enough time to read through the document and then refer back to what you're saying, they can figure out what are the parameters of the software, right? So this is some of the issues that we need to be careful of. So coming back to that, right, when you have to move data across the wire, right, what we recommend is that instead of doing, you know, like a remote OPC DA, anything along that line, do an OPC UA tunnel, right? Do an OPC UA tunnel. So the reason again we recommend that is that, you know, firstly it's encrypted. So if you use the OPC UA tunnel method, you can actually enforce signing and encryption, right? So SHA-256, basic 256, SHA-256 right now, right? So that's some of the things that you can do. So what happens is that when the data goes out of the Kepware to another terminal, right, the data is actually encrypted. So whoever is looking at the data, he will see some rubbish data basically, right? Which I will demonstrate later as well through a screenshot. Then when you do signing, you are able to trust the client. Of course, this again assume that the signature is not compromised, the certificate is not compromised, right? But you know, again, then you also have the username and password. So another layer, right? So multiple layers to kind of authenticate and have some sort of security in place. So that's the 2 point over there. And then lastly, you want to give as little permission as the guy as needed, right? You don't want to open anything that's unnecessary for him, right? So with encryption, again, it looks like this. Instead of a plain text, when you move out of the Kepware to another Kepware, for example, or another UA client, if someone is looking at your traffic, right, it will all be in rubbish, some weird letter, right? So the only thing to note is that sometimes, right, because encryption can be a double-edged sword, right? So you don't know if the problem with the encryption is that if you do encryption, sometimes from an OT perspective, right? For example, if I need to troubleshoot the system for you, I cannot tell what is going on, right? So I need to decrypt it in order to make sense of what is going on. That's the first problem. The second problem is that the encryption can be leveraged by the attacker as well for data exfiltration. They can hide underneath the encryption if somehow they manage to compromise you, right? So again, any form of security security things that you want to do, try to involve your IT team and discuss with them if what is the best thing to do, to understand the risk and all that stuff. So as an example, right, on this screen right here is basically a wire capture. So I'm using a tool called Wireshark. So on the left-hand side, you can see that is I selected none for OPC UA security. So you can see every single thing. You can see that there's a data volume, there's a new data coming in. The client handle is 5314979472. In fact, if you scroll a little bit back up, you can actually see the OPC UA session ID. And then if you go all the way deep enough, you can see that there's a data change for unsigned integer 32, value 0, the timestamps and things like that, right? So you can pretty much see as a lot of things here, right? And then on the right side, if it's encrypted, basically this is what you will see. You cannot see anything. You will be like with a masking code and things like that. So that's really what we mean by with encryption and without encryption, right? So I hope that this makes sense to a lot of you, so that you know that, okay, so if I encrypted, they cannot tell what my system is trying to talk about, right? Because imagine if you're not encrypted, if I look at this traffic, I can tell you the identifier numeric 811 namespace index 0. So what it means is that I'm clever if I have an OPC UA client and I know what I'm doing, I can write things into the systems, right? So that's another issue, right? So again, if you have used the security policy to enforce read only, then that will be another layer of security. So even if they see it, they try to read it, they cannot write to it. So that will be another layer of defense. Okay, so the next portion we are going to talk about is just to share with you some of the typical network designs in OT. Right, so the most famous one, I guess, would be Purdue Model, which I think a lot of people will be quite familiar with. So it's actually a model that is developed in the 1990s. So it's a parameter-based zoning, right? So the assumption is that you have an IT trusted zone, OT trusted zone. Then in the middle we have a industrial DMZ, and then we try to we will handshake everything in the DMZ area, right? So typically this is actually handled by the IT side of things, but for OT people, we need to be aware of this, right? And again, some of the technologies that you may encounter would be like VLANing, routing, firewalls, and data diodes, right? So these are some of the technologies that you can use, right? So when you need to move data, right, you can actually consider having a proxy Kepware in the industrial DMZ, and then reduce the exposure to the OT side of things. Right, so that's one of the way you can do. And when I say proxy server, what it means that you can actually install a copy of Kepware onto the DMZ and then do a UA tunnel that we have seen just now into maybe another terminal or somewhere at this layer, right? So instead of exposing your HMI or SCADA directly to the IT side of things or whatever software that needs it, create another layer, another layer of defense to help reduce but to delay the attacker. So for those who are interested, Kepware, we have actually participated with a real-time data transfer project with Logic. So Logic is actually a The full name is called Linking the Oil and Gas Industry to Improve Cybersecurity Program. Yeah, so it's an ongoing collaboration, and if you want to find out more how we have done some of the testings and things that we have done, the results, just click on the link and you can read more about it, right? On how we actually leverage the OPC UA to provide some of the recommended system deployment. So coming to the DMZ zones, so typically, you have firewall that creates that kind of perimeter defense. On top of that, you can actually add in data diodes, right? So data diodes is a unidirectional device. So with that, you can actually, what it means is that you can enforce one-way traffic, right? So imagine if, let's say, your higher stakeholders, they just want to monitor. They're not interested in any control, right? Typically, that's the situation, right? Your IT side, even your business owners, they just want to see what is the status of the machine. They don't want to necessarily go and turn off and turn on. Usually that will still require human intervention to be sure, So if, let's say, most of the use cases are just like that, you can enforce one-way traffic through a hardware level, right? So the only problem is that most of industrial protocols, they are solicited comms, which means there's two directions. I ask for something and then the other guy will respond back. So they are not suitable for data diode. But what you can do is that you can actually aggregate it using, say, remember just I talked about using an OPC UA, you aggregate the data and then deploy a diode, industrial OT diode that is specifically designed to do this. So today we have ST Engineering's data diode to talk about, which they will talk about in the later section. If you're not using a data diode, however, you need to implement a one-way traffic protocol. So this is our recommendation to do that. So you can actually use the GE-EGD protocol to achieve this. So the GE-EGD Ethernet is a producer-consumer-based protocol that UDP transport. So what it means is that they are one-directional traffic, right? However, there's some sort of limitation because some of the, for example, string data type is not supported. So you need to be careful of that, right? So this is more of the one of the way that you can use a pair of Kepware to achieve this if you need to implement one-way traffic. So this really is meant for those general data diode that do not have OT capabilities, right? And so what you will do is that your access will be aggregated to a copy of Kepware, and then you will have another Kepware on the other side. Then you set them up as the diode producer and the diode consumer using the EGD driver, and then you pass the data across the data diode. So when we talk about data diodes, right? So those are the general data diodes. And then on the other end, we have OT-specific data diode. So today we have the ST Engineering solution that has a purpose-built data diode that is used for industrial applications, right? So later, I think Ken will be talking about that. But in general, you can see that from this diagram, what we'll do is that they can actually use Kepware to aggregate the data. And then inside the diodes, the diode pair itself, right? There's actually a UA client and UA server. And then with their proprietary system or the diode section where they enforce the one-way traffic. So what will happen is that the OT data will be aggregated here, and it will be sent out to the OPC UA clients on the data diode itself. And then the data diode will then pass that data across the layers, right, to the other side, and then we can expose that data out back using OPC UA. So the nice thing about this is that if you're using Kepware, right, what we'll do is that we can actually maintain and retain the data modeling if you've done it on Kepware and pass that data model on a one-to-one mapping. So you don't need to reassemble that data model once you get across it, right? So once it's across it, you can either use Kepware to convert it back to another protocol that you were using. For example, maybe you're still stuck with OPC-DA, right? So you have an OPC-DA SCADA reading back to a Kepware. Or if you have a SCADA that supports OPC UA, right, you can go direct to the data diodes UA server. So again, it depends on case by case on what you have. But this essentially is one of the solutions that we have. So in terms of data diodes, we have two documents right now on our web. So if we have white paper over here that talks about in general, the kind of data diode out there, firewalls and network segmentation, as well as the EGD driver that I talked about in the earlier section of the data diode section, right? Then on the other hand, we also have a connectivity guide that is developed between us, Kepware and ST Engineering. So we actually have a configuration guide for that. So if you're buying a diode from ST Engineering today, you can download this guide and you can actually follow the guide to quickly get your system up. So I think as an ending note, these are some of the links that I think is pretty useful in terms of if you're concerned on OT security, right? So we have the secure deployment guide, which we will talk about in this session. We have a shared responsibility white paper, to talk about who takes care of what, right? And then we have some of the white paper that talk about some of the security strategy for manufacturing, as well as our PTC's CBD reporting webpage. Then in terms of just now we talk about protocol security, if you want to do OPC UA, this is the guide that you can follow to implement that. And then we have the data diode guides. And if you are using Splunk, we also have a guide that talks about how to send the OT data into Splunk Cloud. Right, so this is a summary of the steps that we recommend. Right, so for the last part, the monitoring of the event slot, I will cover it in the last section of the day.
Okay. Sorry, I was waiting for a queue to start. So thanks, Steve. Good morning, everybody. My name is Ken Low from ST Engineering. Today, I'm going to give you a short intro about our company because I see some overseas participants and you may not be familiar or heard about ST Engineering. And then I'll present our data diode product. ST Engineering is a global technology and engineering company established more than 50 years in Singapore. Our presence is in more than 100 countries in the world. We are owned by the Temasek Group, which is the government investment company of the Singapore government, and we are listed in the Singapore Stock Exchange. ST Engineering was established to build products and solutions to support Singapore's Ministry of Defence in land systems, marine, and defense aerospace. As our capabilities grow, we extend our products into other domains such as cybersecurity, which is what you see on the left second box of the diagram. Our cybersecurity team started with 20 staff, and then today we have more than 400 employees. Our cyber competencies have grown internationally and into commercial enterprise markets overseas. So just now in Steve's session, you have heard Steve talk about the Purdue model and also a few options to protect the OT and IT network. Example, the first one of them was using firewall. So very commonly in a traditional network, firewalls are being deployed to protect the networks. And we think that that is secure enough. However, there are some blind spots that we see about firewalls. Largely, there are 4 areas of problems. So let's take a look at the first one on the top left-hand corner, which is insider attacks. So if someone in your organization is routinely trying to break security protocol in your organization, this cannot be solved by any security products because that's intentional and it opens the firewalls to exfiltration. The second problem that we see is the bottom left one, which is the firewall performing too many tasks and overloaded. So some companies deploy firewalls to do not just firewall access list control checkings. They also do configure firewalls to do VPN concentration, IDS, and stuff like that. So it makes the firewall performing too many tasks and overloaded. Of course, there are ways to overcome this problem. That is to deploy more firewalls. But doing that has also its downside, which is increasing the cost, overall cost of operation, and also the overall CapEx cost. So let's take a look at the third problem. On the top right-hand corner, firewalls need to be constantly updated with latest security patches. If the patches are missed, then it exposes the firewalls to vulnerabilities. And if you deploy more firewalls, like the previous problem, then this missed security patches then becomes a even bigger problem. So let's take a look at the fourth and the last problem. We all know changing firewall policies can be a daunting task, especially if the firewall configuration itself is very complex. So the more firewalls that you deploy will increase the chances of human errors in configuration mistakes. So these are the potential problems that will cause a compromise on a firewall. On the left-hand side of the diagram represents the OT network where all the PLCs, controllers, devices are, and they are sending statistics and data into the IT network for analysis. Both entities are separated from the internet via firewalls. Now, if the firewall is being compromised, so assuming you don't see the firewall here, but the firewall is actually deployed into here. So if the firewall is being compromised, hackers can plant attacks into the OT network and take control of the environment, which is what some of the big consequences that Steve shared earlier on, some live examples that OT environment or OT networks have been actually compromised in the real world. By deploying a data diode here, this is picture that you see, this icon that you see over here, it ensures unidirectional data flow, so it stops network-based cyber attacks. All operational data can still flow in, enabling production and day-to-day functions. The data diode cannot be compromised to allow reverse of data flow. So I will summarize, data diode does three things. The first one, to securely transfers data between two physically separated networks, prevents data leakage, and eliminates cyber attacks by enforcing one-way data transfer. It is thus being deployed in three common use cases. The first one, securing IT OT networks monitoring. This is the agenda or topic of today. So it makes sure operational data is sent only one way, preventing any manipulation, and is non-intrusive, which allows operations to run as per normal. So there are two other common use cases of data diode. Second one is the secure file transfer solution. It can actually handle a high amount of traffic while managing its own workload with zero loss capability to ensure the safety and integrity of the data transfer. The third application is Secure E application gateway, which supports the most common bidirectional application data transfer, such as HTTP, HTTPS, POST, and GET. So the key thing about our data diode is the patented one-way fiber optic shown at the bottom of the slide here. It has a T module, which is a laser transmitter, and an R module, which is the laser receiver. Now, between the source and the sender diode, it is running at the network and application layer protocols. Similarly, between the receiver diode and the destination. So let's take a look at the use case on a secure file transfer. So the firewall on the right-hand side, you see here, the firewall that you see here is to protect the archive data storage on the extreme right. So example, if a misconfigured or compromised firewall will open up security loopholes for cyber attacks, leading to theft or leakage of the data in the data storage, or possible injection of malware into the data archive. With the data diode deployed here, it ensures a unidirectional data flow, meaning that all data storage, data and files can be sent into the archiver for storage, but nothing can go out in this direction. So it ensures the data leakage. On a similar use case for data storage file transfer, what happens if the file that is being sent into the data storage is already infected with virus from the source? Example, someone from the trusted network. So the virus or the malware inside the file can actually go into the data storage and corrupt the archival here. So we can actually deploy a file cleansing solution in between two data diodes to ensure anything that goes into the system is completely threat-free, meaning that the file cleansing solution will scan and clean any virus or malware that is present in the file itself. So we have come to the last slide of my presentation. We have two series of data diode shown in the middle. The top one is our 3000 series and the bottom one is our new 5000 series. Later on in a simple demo, we will demonstrate the 5000 series where we have our data diodes and Kepware's CapServer EX being installed onto our 5000 series data diode as well, to do show a simple demo. The 5000 series is our new product range. It has the key features are zero loss file transfer with file loss detection, higher performance, higher throughput, up to 20 gig BPS, high availability, and small form factor. Now on the right hand side, you see our security certifications. We are certified by Common Criteria EAL4+, and NIST certification by CSA Singapore. So we also have two patents for our data diode. One is on our unidirectional SFP+, which is this module that you see connecting connected with the yellow optic fiber optic. And the second patent is the file loss detection capability. So with that, finish my short presentation, introduction of our product, and I will pass the mic back to Steve for the live demo. Thank you.
Thanks, Ken.
Let me just check through the Q&A as well.
Hello, everyone. Hello, everyone. Can you hear me?
Cannot hear you.
Unmute. Hello?
I think mute.
Can you guys hear me?
Can hear you now.
Okay. Hello, everyone. So I'm actually here to continuing the session on the demo of the data diode system. Right. So if you can see on my screen, wait, am I sharing the right screen? Yeah, correct. So if you can see my screen, you should be seeing a recording, a live picture or live video or live stream of our actual setup. So you can see that on the right side is actually the OT systems that we have. So it's just a bunch of PLCs that we have right now, right? So nothing too fantastic. You can see Ken on the background, but you know, this is the OT section of the setup. So what we're representing over here is actually the OT assets. So we are connected to actually directly to the Kepware that is deployed inside the sender node. So within the 5000 series itself, right, there's actually capability to deploy the Kepware inside the data diode along the data diode. So you can see that it's actually a very nice 1U form factor that can do everything. You don't need to find another computer, install another Kepware, and all that stuff. You can straight away preload Kepware together with the data diodes. And then what we do is that we have a copy of Kepware that is connected to the OT and passing it on to the sender node. And what the sender node does is that it will then pass the data through the fiber optics to the data receiver, right? So this is the portion that enforces the one-way traffic. And then once you get into there, we can then recover the data in the same data model that was configured on the source Kepware, right? So what I'm going to do now is going to show you the instance of two instances of Kepware we have. So on the left side, the top 5 unit is actually the Kepware that's directly connected to the OT system, right? So I'm going to just reduce my quick clients, right? And then you can see this. So you can see that our the drivers used here are the real OT drivers. So this is the Mitsubishi driver. This is the Modbus TCP, and things like that. So you can actually have a direct connection. So for the demo purpose, we're actually doing a direct connection. Again, if you recall what I told you just now, you probably should be using an OPC UA tunnel to do this, right? So we're actually connecting to it. You can see the sensors are moving here, the data are going, and all that stuff, right? Just to show you that Steve is not doing some simulation to trick you, I will open my comms diagnostics. In a moment. Okay, I will show you the comms diagnostics. In fact, this is a good opportunity to talk about plain text traffic. So let me just open this up. Okay, so you can actually see that comms diagnostic for the Modbus sensor, we are actually doing a real-time data. So you can see all these TXRX, right? These are actually the transmit receive events that's happening. So you can actually see that if it's actually really in plain text. So if I look at this data, I can actually tell you are using function code 3, which is a read holding register call, starting from 000018 all the way to, and you're reading a bunch of text, right? So these are what we mean by plain text traffic. Okay. So so going back to the demo, you can see that we are now connected to it correctly. And what later my friend Qifeng will actually talk about is how to connect that to the ST portion of the data diode, right? So I just want to cover the Kepware portion here first, and then on the other side you can see that we have transmitted the same data across the data diode, right, in a real-time manner, right? And you notice that the driver used here is actually just the OPC UA driver, right? And then if you go and browse the UA endpoint of the data diode, you can see that the data model is actually preserved and then being sent across, right? So you don't have to remodel your data. A lot of times when you do data diode, sometimes you have to rebuild that data once the data goes on the other side. So with a OT specific solution like this, you can actually transport the data model across as well, right? So again, as another proof point, I'm going to do something very risky here. I'm going to write into the we can actually attempt to write into it, and then you should see that the camera, there's no reaction on the OT system, right? So you can see that there's a light over here. If I try to write something into it, you see that the data is sent, but it doesn't go through the network. See, it doesn't move. So that really is one of the key usage of the enforcement of the unidirectional flow. And I will now hand over to Stephen, who will talk about the rest, how this is being configured from the ST's point of view.
Okay. Hi everyone. Can everyone hear me? Okay.
Yes.
Okay. So actually this is the user interface, the graphic user interface of the ST Engineering Management Portal. So how we can configure it is how the diode is being configured. Everything is done on this portal itself. So you can see we have one portal for the sender, and then we have one portal for the receiver. So how you connect is basically we enter the IP address, and then we just log in with some pre-configured username and password. Okay, so on the sender side, what we need to do is just to configure the IP address. So for this example, we are using this IP address for the data diode. So how the Kepware on the source side communicates with the data diode sender will be based on this IP address. Okay, next we will have to configure the OPC protocol. So same thing here, we have to set an endpoint. So this will be what the Kepware source is, okay, as well as the port. Right, we will input all the different nodes, right, that we need to replicate the data across the data diode, and as well as the reference. So basically, you just click add, and then just key in the parameters. So this is after this is done, you just save. And on the sender side, what needs to be configured, same thing. On the receiver side, what needs to be configured is the same thing. You need to enter your IP address of your data diode receiver. Okay, and on the protocol, same thing, OPC UA. Basically, you just need to put in the for this instance, we're actually using the data diode receiver as the server. So the Kepware on the destination side will actually fetch the data from the data diode receiver rather than the data is being pushed out. So this one is very straightforward. It's just the default setting. So this is all there is to set up actually for the data diode for this integration between Kepware and the ST engineering data diode. So maybe I would like to share some of the other functions as well. We mentioned earlier regarding access control. So just like the Kepware system, of course, you need to have some form of access control. You cannot let everyone just access the data diode. So we have our own, we can set the password here as well. We can also add users. So all these users, same thing will be, you can allow certain roles. So you don't allow every user to do everything. Similarly, everything that is being done on the diode, the management portal is being locked down as well. So you can go into Lockin logs. You can see who has logged in today. Okay, you can look at the audit logs and see what has been done today. So all this has been locked down as well. So same like the Kepware, everything is being locked down. So if there's a need to trace back to try and figure out why certain things went wrong, all this can be done quite easily. So not only that, on the receiving side, same things, you have all the logs as well, but we have also success logs and file loss logs. So in the event there's an outage or a breakage of connection, maybe somebody unplugged the fiber cable and you want to find out when this happened or what file has been lost during the this outage. All this can be actually traced back. So we can see actually today there isn't any file loss detected yet. So this file loss detection was what Ken previously mentioned. The patented one of the patent that we have been granted. Yep. So this is basically it. If you have more questions or if you need more a more in-depth sharing, you can always approach us and we can continue this conversation. So without further ado, I think we can hand over to Alvin from Stratus. Yeah, so he'll continue with his sharing. Okay, thank you.
Okay, hello, good morning. Let me share my screen first, okay? Just give me a second while I pull out my screen. Okay, almost to. Can you see my screen here?
And can.
Okay, okay. So it's good. Okay. Good morning. My name is Alvin. So I'm happy and honored to be invited as a speaker for today's session. So to show you who is Stratus and how we can help on the security end, as well as how to ensure the availability for OT security. And for start, let me just give a quick introduction of myself. So I am actually the system engineer, okay, or pre-sales for Stratus, covering the Asia South region. And I mean Asia South is in Southeast Asia region, on the Northern Territory, all the way to the southern part of Singapore, such as Philippines as well as Indonesia. So today I'm going to share with you, okay, to give you a short introduction on our technology and to provide an overview on how we can help your customer and where we are heading in the future. So companies around the world has been relying on Stratus to meet their availability needs for the past 42 years, because we are founded in 1980, and our expertise is reflected in the numerous patents. And so far, we have deployed over 20,000 systems worldwide, and it's still growing. So with some of our latest portfolio that we introduced in three years back, 2018, right? We have gained a lot of foothold in a lot of industry, particularly on the below. You can see on the industrial automation all the way to process manufacturing. So we are also in some of the IT fields, such as telco, telecommunication, as well as financial services. So we are actively evolving in our technology, okay, and growing the business to support new industry and market all the time. So anywhere across the globe. And just for a start, right, our presence is in a worldwide presence. So we have a call center in America, EMEA, Europe, Africa, as well as APJ, the whole of APJ. Okay. So this is how we can introduce to remove the complexity from availability. So you can see that a lot of solutions on availability are quite complex nowadays, and it is growing with all the demand and the trend that is going, right? As mentioned earlier on by Steve, the complexity for just using Kepware together with the OT security, it can become very complex. But yet at the same time, there is a need for availability in various industries over here, as you can see from the icon. For example, manufacturing, robotic, smart city, even on financial. So we, Stratus, will come in to remove the complexity of setting up the availability, right? So to give all your partner or even the user peace of mind when using it, to ensure that their services are always running without any worries. Okay, let me tell you and share with you why this matters to you. Today, the ability to operate 24/7 is matter more than before. So why is it so? The world has changed. In the last 10 years in particular, we have seen an increasing amount of software and computing in many different industries all over the world. Just take an example, for the past 10 to 12 years, we have been talking about the industrial automation or the industrialization 4.0. So it has evolved from 3.0 to 4.0. And with 4.0, we are expecting a lot of automation. That means as minimal user or labor intervention as much as possible to harness the capability of robotic or automation to get all the job done. And with that, more and more software computing resources are required. And since the dawn of internet, we have become more oriented towards that on demand. Anything of this all the time in terms of the compute, in terms of the internet connectivity, or even on the network connectivity. we're not just seeing this in a traditional computing environment, in such as the FSI industry. It also apply or applicable to a lot of industry like manufacturing, travel, transportation, public safety, communication, in virtually any aspects of our life that you can see. Sorry, let me just pull up laser printer. So these are just some of the sector that we can, or in fact, there are a lot of requirement for mission critical and critical infra that need to be there to ensure all these services or operation run without any glitch or even disruption. This is very utmost importance to that. Okay. So just think of it, if the services or the application goes down, the impact to a particular sector or even on their business can be very significant. And the cost, that means the monetary cost to the business, is only increasing. So according to Aberdeen Group, the cost of downtime actually went up from 260K per hour on the average between 2014 and 16. And across many industries, the cost of unplanned downtime is significantly higher than the total cost of planned downtime. In 2016, a study from the ARC Advisory Group discovered, they did a research, right, that the cost of an unplanned downtime incident is roughly about 10 times the cost of planned one. So this actually hit the top line and the bottom line business in terms of the revenue. I'm not sure whether you guys have heard of it before. In this year, there was a very big news on the pipeline. Ransomware was hit in US, right? So during that, the unplanned downtime actually happened. And while the engineers or the guys are scrambling to recover back the data, right? Although they still have the data with them to recover everything, but that constitutes as a downtime altogether. So where I'm coming from is with a proper planned security, OT cyber security in place, plus availability, this can be mitigated. In fact, it can be avoided totally just by having all this planning in place, and they will be able to avoid having to pay such a high cost in terms of the downtime that has happened. Just a note, in the petrochemical industry, right, the impact of unplanned downtime actually can result not in terms of the absolute amount. It actually equates to about 2 to 5% of the productivity loss on average. So just imagine in this industry that is from the petrochemical, to them, it equates to millions or billions, even billions of dollars, right? In term, just by that 2 to 5%, because what they are doing is like many billions per annum. So just imagine this is the monetary loss that will happen to them. In not only that, right, to the financial impact, in terms of the brand and reputation consideration, this impact is intangible. So it can be in a way that when the service disruption happen, right, their image will be tarnished to the public point of view. So it's like, why are you keep having such a downtime to prevent me from using your the services? So as you can see from the logo here, we are a proper planning of availability. Again, take for example, just happened last week for those who are based in Singapore. Just last week or across the region, who is utilizing our largest bank in Singapore, we actually experienced a downtime of about 2 to 3 days. 1 to 2 days. Okay, although they claim that they have recovered in a single day itself, but you guys get a feel that it's not really working. So this is due to their access control. But in the news that we see that is access control, but perhaps at the back end is something to do with the way they design the availability as well as the their security. So this is, again, I can't stress enough that availability and cybersecurity have to work hand in hand to ensure that there is no disruption to the services. Let me move on again. Okay, so as the impact of unplanned downtime increase, right, the demand for availability solution is growing also. And you can see from here, the new technology that coming up, right, such as industrial IoT, there's a lot of Internet of Things 4.0, digital city, smart city, even on the EVs car under the smart cars category, smart edge appliances, which I can relate to something like the solar, sustainable energy or renewable energy. At the same time, it can also apply to the next gen farming. So all these industry are growing. It is a need that we foresee that in the next 5 to 10 years, it is that direction and trend that we are working towards. So and all these trend, there is a common requirement, I'll say the standard, and that is it needs to be simple to operate. It needs to be secure. It needs to be integrated and within a ecosystem, right? So these are the requirements, and not forgetting that it has to be resilient, autonomous, like as I mentioned earlier on, as minimal impact to the human or labor operation as much as possible. And of course, there will be a lot of compliance and regulation that is out in the market by all the relevant authority. So all these, again, availability, cybersecurity will be in place. And according to this VP of Research by IDC, that he quoted, in this world of data that exists today, the criticality of analytic and IoT to business to real-time process, it means 100% availability at the edge or in this relevant context is a must for decision-making and optimal consideration. Okay. So just let's talk about some of the trend. Okay, we know that the trend of the next gen is growing, but at the same time we have to ensure that the availability solution is also growing, right? So this is some of the slides. This slide is just doing a high level comparison on the kind of solution that the availability have evolved throughout the years. So for a start, many of the traditional IT approach to availability are not necessary. Okay, so standby server involve very manual process. In the event of a failure or application hack, somebody will need to walk over to recover it. And by doing this way, this is a very traditional way. So in an operation environment, this is unacceptable. So because it's inefficient and doesn't offer any kind of data protection at all. Other option, the next one will includes disaster recovery or even HA solution. It involves some degree of this will involve still some degree of data loss in the event of a failure. Okay. In addition, as you move across the spectrum, the cost and the complexity of the solution goes up. So it's very based on the operation, it's very easy to write out an operational manual, right? To how to recover it. But again, it is very structured. It is, if during the steps of the operation in the recovery will happen, right? There's any issue or any hiccup, right? The guy on the ground will not know how to react on time, and by delaying this process, it will equate to further downtime to the operation as well as more data loss. So how our structures will come in, right, which I'll explain in the next few slides, right, is how can we do to prevent all this happening, right? Our structure solution, we focus on three values. We design our product and as well as our solution, right, from the ground up based on these three value and benefit for our user. First, it has to be operational, simple to operate. Right, I hear some background. Is there any question, or maybe I should just continue? Okay, I think he forgot to mute. Maybe let me just continue. I'll tune down my volume higher so that you guys can hear. So the value that we are the benefit, right? We design our solution to be simple to operate, right? To ensure that it is always available. In fact, our solution is able to give you an SLA or even the downtime, right? Unplanned downtime of up to 5 nines. So when I mention 5 9, right, it means that it's no more than 5 minutes per annum. Compared to if I take away another 9, it will become 4 9, and that will equate to 1 hour of downtime for unplanned downtime. So 5 minutes versus 1 hour, that's a substantial amount in terms of operation and in terms of data integrity loss, right? And last but not least, on cost effectiveness. So our solution, we design it to be cost effective against our equivalent availability solution out in the market. If you do a comparison as a whole, right, you will see that actually there is we have a very significant cost saving. Okay, let me continue. So that's all I have to share in terms of our solution for now, right? Just remember that we remove the complexity out from availability by working towards this solution. It has to be simple to operate. It is always available and cost effective, right? And moving on to the next slide, I will just give a few introduction on how we are relevant in the cybersecurity, as well as giving you a high-level view on our product solution. In the cybersecurity end, right, Stratus, we design, okay, we adhere to these 2 framework that is internationally recognized. First is the ISA, right? And second one, ISA for info stands for International Society of Automation, and the second one stands for is NIST, which is in US recognized, and it stands for National Institution of Standard and Technology. So you can see from here, in the ISA, we actually design our solution, okay, and the ISA, it comes with an IEC guideline 62443-4-1. 1 stands for security process, -2 stands for product security. So what it means is that we design our solution based on the security process, and we design the product based to enhance security by adhering to ISA IEC guideline, right? So you can see on the chart here, this is the requirement, IEC 4-1 and 4-2. Next, on the NIST end, they actually ask for FIPS. Okay, so FIPS is actually a crypto as well as a data security design algorithm principle that they set in place. So our solution also comes with FIPS level 2 in place. So in the I think this FIPS, a lot of you guys are very familiar with it, because in a lot of government tender, this is a minimum requirement for them. In an event that if there's some compromise of the data, how can they prevent it from become readable? So this FIPS level 140 level 2, right, is the one that they always emphasize on. And of course, last but not least, they actually have this publication 800-33 on a framework for risk management. So we adhere on the design framework based on our cybersecurity design framework based on this, right? Last, I'll move on to the product portfolio. What Stratus have to offer in terms of our product and solution. So for customer, okay, or your partner who is transforming their operation in order to drive reliability, at the same time to ensure that their performance operation at peak with optimal optimization, right, and minimal risk, we can cater to this portfolio, Stratus portfolio. We have 2 product line and a software line. So first on the software, here, this is our software. We have the Stratus Everrun solution. Everrun, okay, by the name implied, it support virtualization and is deployed on any commodity off-the-shelf x86 server. And the server can be separated across 2 data centers, which provide real-time or basic disaster recovery. Next, we have the Stratus FT server platform over here, which is our flagship product, which fall under the hardware line. So FT server is what we call a turnkey solution, okay, customized out of a box appliances that is able to look with choices of your operating system, either VMware, Windows, with from Microsoft, with or Hyper-V for virtualization context. So you are able to consolidate all the workload into a single Stratus FT server to perform all the workload to ensure that they are provided with up to 5 nines of service reliability. Last but not least, we also have the choices of installing with Linux. Okay, so this Linux, right, is I would say predominantly we are very popular with a lot of financial services solution, because we do have some of the solution that they ask for OpenShift, and we will install them with Red Hat, and they will be configuring it with OpenShift for all the orchestration of their containers. Okay. Next, on the other hardware end, we have our 2nd generation edge appliances, which has just been released or GA last month. So this is think of it as FT server, right? But our positioning is to ensure is to be deployed in a very remote location or even in a harsh environment, and we will out of the box, right, provide you with the availability such as high availability all the way up to fault tolerance. So it depends on the choices of availability that you want to select. It can be deployed in under 30 minutes, but even by a non-technical user. So again, it is built for industrial edge environment. Edge environment means that remote area, where there's a lot of operator there, but without any minimal IT knowledge, they are able to just do the servicing themselves. Okay, out of the box is protected and monitored by our Stratus monitoring. So, and it is in a virtualized environment as well. We provide a virtualized environment, okay, powered by our Stratus redundant Linux. So what it means is that we are able to again consolidate couple of the workload within this appliances. By the way, I forgot to mention, this is what we call our ZTC Edge, right? This ZTC Edge over here, as the name implies, Z stands for zero, T stands for touch, and C stands for compute. So it stands for zero touch compute, meant for the edge. So what it means is that we are able to fulfill a high availability of up to fault tolerance level, right? For the redundancy, to be deployed in a remote location by you, yet at the same time is able to recover or service by anyone without IT knowledge. Okay, so with just some of the last 2 slides I have to share, right? We have been gathering a couple of awards throughout the years that we have launched, right, or in the market. One of the notable highlight will be by Singapore Business Review. Okay, so we are awarded for the computer excellences in the aerospace at this year's annual technology award event. So from Singapore Business Review, they actually mentioned that this recognized the company that have pioneered groundbreaking IT product and solution. So we have revolutionized the market with our fault tolerance technology, right? With fault tolerance technology, we are one of the offering. I believe so far in the world, we are the only one that is able to provide hardware fault tolerance out of the box. Okay, last but not least, on the ZTC Edge, we are being awarded in Edge Infrastructure Company of the Year, right? And this is by Frost & Sullivan, and it is this year only, right? So what they have awarded us and mentioned us as supersede many of the competitors, as the ZTC Edge is the only purpose-built edge solution that enables simple and always available virtualization for critical IT and OT operation. So in a way, it is our tool solution is able to provide availability out of the box up to fault tolerance level, and at the same time we adhere ourselves to a cybersecurity requirement. So with that, I'm just finished my brief introduction to our solution as well as product and how we are relevant and how we are able to help in term for your partner or customer on the availability area. Is there any question? Let me just check.
Yeah, can I? So I will assume that you guys are looking at the correct screen. It's the PowerPoint, right? Okay, hi everyone. I'm covering this section, the last section for the day, which is how to monitor Kepware. Right, so something that I think you guys can do if you want to. So what kind of data is available for monitoring of the CapServer platform? Right, there are three major areas that you can look at. So the first one is the OT data. Right, any data that you connect to Kepware, you can use that data in somewhere for your monitoring, right? For example, you can connect using the SNMP agents to the managed switches and things like that for you to look at the the MID file and then what are how is the network like. If you're using UPS, you want to monitor your backup power, you can use the SNMP driver as well. If you need to send data out to somewhere else, you can use the SNMP agents plugin. For example, you have an NMS, you want to send it out. You can also use the Kepware to do it, right? To bridge the OT data into the SNMP or IT side of things, right? Then for the next thing that we have, right, that I think not a lot of people are aware of is the underscore system tags. So the underscore system tags are a series of system generated tags by Kepware to give you information about your connectivity to the OT asset, right? So I'm going to cover a little bit on that as well. And last but not least, we have the events log, which is very useful for troubleshooting, especially the OT people. You can actually use it to usually we use it to troubleshoot the connectivity issues. So things like this can also be leveraged, to do like anomaly detection, to see whether there's any unauthorized access or anyone who opened the configurator that is not supposed to, login failures, things like that. Those are all logged into the events log. So there's a way to actually extract that through the configuration API, right? So that will be the coverage on that. So for the OT data, I think because we're not going to cover the basics of here, but once you get the data inside, you can actually use it to service that data out. So if you use the IoT gateway, you can actually send out the data to provide a REST config API for other software to pull in, right? For example, you could be using an ELF stack. Then you want to you can actually write a small little script to pull the OT data out of this platform into your monitoring tool, right? Or if you have an NMS in place that uses SNMP, you can use the SNMP agent to do just that. So if you look at our screen over here, this is the IoT gateway where you can set up the REST server or REST client on it. By doing so, you offer yourself an API for other software to pull. And if you're using the SNMP stuff, if you go under the SNMP agent, you can actually create your own SNMP mapping and then export that MID file out and pass it on to the NMS. And they can actually use SNMP to connect to the Kepware to look at OT data, right? So that's another avenue that you can consider. Then for those who are using the more popular, one of the most popular SIEM like Splunk, we have a specific plugin for that. So under the IDF for Splunk, if you create the host name and the port number, you can throw in all the different data into the Splunk platform itself. So that will be how you can push OT data out to other platforms for monitoring. Then when you want to talk about underscore system tags, so this is the stuff that we have. So if you look at if you try to browse a OPC DA or just browse the server itself using a UA client or even the OPC DA interface, you should be able to see a bunch of underscore tags. So underscore tags are internal tags created by Kepware, right? So if you look at this particular screen here, we have the root underscore system folder. which underneath you can actually see the data about the running instance of CapServer EX. So you can see how many clients are connected. Things like, for example, you know that in this system, there's only one HMI, maybe a redundant system. So there should be only a 2 counts of Kepware in a normal operational status. So you can actually monitor this type for abnormal changes, right? For example, things like, so certain cases where maybe a HMI is trying, there's some bug into it, and then it starts to connect and doesn't disconnect. So it increases abnormally, right, to 100 or 200. That's where you know that something's going on the software itself. There's a lot of client connecting, right? So hopefully it's just a software bug from HMI or another client, not like a real cyber attack where they're trying to do deny a DOS on you, right? So hopefully that's not happening. But if you want to look at all these parameters, they're all available in the underscore system text. So this one also provides you with things like the project full name, so you can tell whether where the project file is and what project file is being run right now, right? So you can, if you have some sort of enforcement or nomenclature of naming your project, you can actually use it to monitor for abnormal changes to the project, the runtime project. So the next thing that we also have is a bunch of time tags, right? So time tags are useful in the sense that typically in OT, we'll use it as a heartbeat signal, right? But if not, on a security perspective, you can also just take a look to see whether the time is in sync with with your rest of the systems. Right. So underscore system tags provides a rich environment, a rich bunch of data about the platform itself. And then at the device layer, if you create a device in Kepware, you'll notice that they will also have an underscore system attached to the device itself, right? And what that does is that at the device layer, what you can actually see are some of the things like the error status and state of the device. So if you look at this screen over here, right, these are the underscore system tags. Again, you can see how many tags are being created, whether it's in the demotion mode, whether there is an error, whether it's a connect timeout, right? So you can actually use it to monitor the health of the system as well, right? And then on top of that, if let's say you're interested, we also have the stats tag. So the underscore statistics allows you to look at the number of the volume of traffic that's going on right now. So you can see that there's nothing going on right now, 0, 0, right? But if let's say there's something going on, you can actually see the number of successful reads, successful writes, and TX, RX, and things like that. So you can use it to monitor the health of the connection between Kepware and the asset using the underscore system groups, right? Either use this guy or that guy. They can achieve that objective, right? And then on top of that, when we talk about events log, right, the recommended way to pull out the events log, or rather the only way right now, is to use the configuration API, right? So for those who are not acquainted with it, on version 6 onwards, we actually offer a REST API. You can go into this link, right, and you can actually see the guide, step-by-step guide on how to enable the configuration API. And then from there on, you can actually issue a specific URL to pull out the information from the Kepware events log that we're all used to, all this information into a REST format. So you can actually use it a REST call. You can use a script, to actually pull it out and send it on to, IT systems for further monitoring. Right. So this is an example from Postman. So if you follow the guide, you can actually enable the endpoint on Kepware, which is disabled by default. So you need to specifically enable it. Remember, we disable unused interface by default. So you need to enable it, explicitly enable it. And you shouldn't be following my screenshot over here, because you can see that I allow all origins. So you probably have to define it if, let's say, you're using the core stuff. But if not, you're doing a script, then there's no need to bother with that. And then there's two variants, HTTP and HTTPS, depending on your scenario. You may want to use either of that. And what it does is that when you click any of this link, you'll be redirected to the documentation of the configuration API. So once in the configuration API documentation, what you can do is that you can check out all the different endpoints that you can call to find out information about the CapServer EX that's running right now. So for example, in this case, you can see that I issued a GET call into the project URL. And what it does is that it actually brings me the server interface in the JSON format. So I can actually see that, OPC DA is actually being run right now. So if let's say, going back to the earlier session, you are supposed to disable it, and then you have some sort of monitoring tool seeing this, that somebody enable it, then something is going on, right? So this is an example for the events log extraction. So you can see that if we do, we actually grab the, you issue a get call to this endpoint, you'll be able to see the data over here represented as a JSON format. Okay, so before I go over there, maybe I'll just do a quick demo on this. So you can see that over here at this URL, we can actually see the documentation, right? So in terms of documentation, there's a couple of things that probably would be of interest to you. Let's say if you're from the security standpoint, we have the transaction log, right? Transaction logs are endpoint that you can call to find out what has been called to the API endpoint itself, right? And then if you go to the API documentation and you scroll all the way down, you will be able to see that there's an endpoint that says events log, right? This events log is the events log that we're talking about over here, right? So anything that happens within Kepware, typically we will give some user meaningful data over here. And what is that? What it does is that if you issue the get command to these points, right, and then you do a get call to it, you should be able to see the JSON representation, right? The JSON representation of the events log. So you can see that over here we have the information event. So this information events refers to the information type, right? So you can actually see all the different types of events. And the source, where is it coming from, the runtime, or is it coming from some plugin or anything like that? So you can even see that somebody has created the text, right, through the automatic generation. So if let's say that is something that's not supposed to happen during production, and you're actively monitoring the events log, then you can be alerted to it, to see who's doing something that is not supposed to happen at this moment of time to someone. Hopefully it's some engineer who forgot to inform you, not some malicious software. So hopefully that's what's happening. So this is one way of extraction of the data. And if you leverage all the three kinds of data, you could be building a dashboard that looks fairly similar to this. For example, you can be monitoring the Kepware system itself, right? So the system tags of the Kepware, you can look at the time, you can look at the version, right? If you have the version info and you correlate with the CVD disclosure, you can actually find out whether your systems are they all running on the latest version and what kind of vulnerability is being shown right now based on this version, right? Then on top of that, you can also see the client count. If you think that there's not supposed to be anyone reading right now, 0 is the normal one, then you set it as like active. And then when it goes above 0 or a certain range, you can have an alert coming to you, and then you can investigate, right? So these are example of leveraging all that data using the IDF for Splunk plugin. And then on the other side of things, if you have network devices, and you want to use our SNMP or ping driver, right, you can also use it to take a look at the connectivity status, right? And at the bottom is the events log. Remember the get call that we did. So basically, we use the same thing and pass it on to a Splunk in this scenario. And then we visualize it using a table format. And you can actually see that there's some error happening to this particular instance of Kepware right now. And there's some config security information right now. You can actually see that this guy has connected to the REST client, right? And then there's a user called Kepware AP who opened the configurator as a default user. So you can see all these things, information, and use it to give you a bird's eye view of the status of that particular instance of Kepware and monitor it in the security perspective. Okay, so as an ending note, this is what we have covered in general today. So you can see that we, Alvin actually covered about the use of the Stratus solutions to provide you with availability at this layer, right? So Stratus is able to do that. And then we move on to talk about how you can actually harden the instance of Kepware that you have, right? So you could be hardening it and then providing a proxy server to using OPC UA tunnel. Then after which, once you get the data across to say an aggregation server, you may actually pass it across DMZ or another network layer to another software, right? So that can then be further improved with deployment of industrial data diode from SD engineering that we have demonstrated today. And then what it does is that the information is then being pushed upward to other software where you can actually either use it for security purpose, or it could be doing an IoT application scenario. And remember that we also demonstrated that when we try to write into that software, the data doesn't flow backward because there's a data diode that is in place that is enforcing the unidirectional flow, right? So in that sense, if anything, somehow that area get compromised, things will not go through that layer. Of course, that doesn't prevent you from people overcoming your air gap or stuff like that. But that's another topic for another time. So pretty much this is what we are showing in a complete view today. So I hope that everyone has a better understanding of some of the things that Kepware and our technology partners can offer if you are looking into your OT security today, right? So if you have any questions, please feel free to reach out to our sales from Allied, and they will be able to link you up to the respective technology partners for whatever solution that you need. Just feel free to open a conversation with them, and they will be able to get back to you